Okay, I'm introducing both the sine and cosine functions here. Today's assignment will be on IXL, and you'll notice it only deals with the sine function. But we're going to introduce both of them here, and you'll see why they kind of get introduced at the same time. Now, of course, if I have no idea what the function is supposed to look like, I can also make a table. All right, I've got inputs, I've got outputs, pair them up, plot some points. And of course, if the plots make a straight line, I connect them to a straight line. In the event of something like a parabola, well, then we try to connect them with a curve. So what will sine and cosine look like? Well, we've got to find out. So let's start by graphing y equals sine of x. Now, so I don't confuse myself too much, I'm just going to label one column input and one column output. Because even though I'm going to try to graph this function on xy Cartesian coordinate system, where x is the input and y is the output, I've got to figure out where these numbers are coming from. And so I'm going to look at that unit circle. And when I'm looking at the unit circle, the input is the angle theta, and then the output is one of those Cartesian coordinates. And of course, in the case of the sine function, it's the second coordinate. Now, if I'm at radians measurement of 0, the value of sine is 0. If I move to pi over 6, the value of the sine function is up to a half. Pi over 4 corresponds with root 2 over 2. Pi over 3 corresponds with root 3 over 2. And we finally get to the top of the circle at pi over 2, where sine now has its maximum value of 1. Notice on the unit circle how the points for pi over 6, pi over 4, and pi over 3 are kind of clustered together and not all that close to 0 or pi over 2. We'll kind of see that clustering when it comes time to actually make our graph. Of course, as I continue around the circle, the value of sine slowly begins to decrease. When I finally get halfway around the circle at pi, the value of sine has returned to 0. I'm only halfway around the circle, got to keep going. 7 pi over 6 sine is now into the negatives. It's negative 1/2. At 3 pi over 2, sine hits its minimum value of negative 1. And of course, as I complete my journey around the unit circle and I reach 2 pi, right back where I started, sine returns to 0. So as I go around the unit circle, sine starts at 0, goes all the way up to 1, returns to 0, goes all the way down to negative 1, returns to 0. So let's graph this. Notice on the graph paper, the vertical axis I'm counting by ones, but on the horizontal axis, I'm going by pi units. Of course, pi is about 3.14. So if I was using standard graph paper, pi would be a little bit past 3. Okay, we start at 0, 0, right? If the input is 0, the output is 0. Oh, before I start plotting points, I should point out 1/2 is 0.5. Root 2 over 2 is about 0.7. Root 3 over 2 is about 0.866. Okay, so we start at 0, 0, right? Input is 0, output 0. So x is 0, y is 0. Then I move the pi over 6. I'm at a half. Pi over 4, I'm a little bit higher. Pi over 3, I'm a little bit higher. Pi over 2, I max out at 1. Now notice how some of those dots are kind of clumped together. Just like on the unit circle, there's a bit of a gap from 0 to pi over 6. Just like there's a bit of a gap from pi over 3 to pi over 2. Of course, now we need to slowly return to 0. And when I hit pi radians, the value is back to 0. Now we have to go all the way down to -1. So as I start plotting my next few points, I get all the way down to -1. And then I slowly return back to 0. So there is one trip around the unit circle. The value of sine starts at 0, goes all the way up to 1, returns to 0, goes all the way down to -1, returns to 0. That is one complete cycle, also known as one period. Of course, I can go around the unit circle more than once if I want to. And of course, I can always run backwards if I want to. So that sine wave will keep going. And because it keeps going, I should really add arrowheads to my curve. There, now I've got arrowheads on the curve. Although I'm going to ask you to do some graphing without technology. Notice that if I go to desmos.com and do the graphing utility, sure enough, their sine wave hits 0, 0. At pi over 2, it hits a maximum of 1. At pi, it returns to 0. At 3 pi over 2, it hits the lowest point of -1. And then at 2 pi, it's back to 0. Notice when it's crossing the x-axis, I can graph a line with a slope of 1. And say, hey, when we're at 0, 0, it looks like the slope is 1. Look at how smooth the top of that hill is. Look how smooth that maximum is. In fact, I can draw a tangent line that has a slope of 0. And it's a really nice fit there. Next intersection, instead of a slope of +1, it looks like there's a slope of -1. And then when I get to the local minimum value of -1, again, a horizontal line will be tangent to that. And then as I complete, whoops, missed one. I'll have to put the PowerPoint without the audio up there so you can see what would have happened with that last one. But it would have been back to +1. Here's another screenshot from Desmos. Notice I panned out. And notice that sine wave keeps going forever and ever and ever. Notice it still never goes higher than +1 or lower than -1. But it'll go on toward positive infinity, it'll go on toward negative infinity. Cosine of x is very similar. Now you notice with sine, the only points that were of real interest were any place that intersected the x-axis and then the maximum and the minimum. So when I'm starting to take a look at cosine, I'm like, okay, I'm going to kind of cut to the chase. I'm not going to go for every single point here. I know there's a maximum value of 1 with angle 0. I will slowly get down to 0 at pi over 2. The minimum value of -1 occurs at pi. And so look what's happening here. Again, this is off of Desmos. Sine goes through 0, 0. But cosine actually starts at its maximum value of 1. Well, sine slowly goes up to its positive value at pi over 2. At pi over 2, x actually hits the x-axis for 0. So sine kind of looks like a hill and a valley. If you look at the sine wave, it starts at from 0 to 2 pi. It makes a hill and then a valley. Cosine kind of looks like a big valley. Between 0 and 2 pi, it starts at the top of the hill at 0. It ends at the top of a hill at 2 pi. There's a big valley in between. This animation is showing you where these curves come from. As I run around the unit circle, each point on that unit circle corresponds to an angle theta, and each one of those points has 2 Cartesian coordinates. The first one, of course, is the coordinate for the cosine of that angle. The second one is the coordinate for the sine of that angle. And I can run around that circle and run around that circle and run around that circle as much as I would like. And as I continue to run around that circle, the sine wave and cosine wave go on forever and ever and ever. So one big thing that we want to note is that whether we're talking about the sine wave or the cosine wave, the period, if we've done nothing to the function, is 2 pi. So if I just want to graph y equals sine of x, or if I want to graph y equals cosine of x, the period is 2 pi. That's one complete cycle. Again, here it's a little bit more obvious why I say that sine looks like a hill than a valley, while cosine looks like the big valley. Also, both functions never get higher than positive 1. They never get lower than negative 1. We call that an amplitude. We say, hey, the amplitude is 1. It never goes higher than 1 above the axis, never goes more than negative 1 below the axis. And again, the key points, whether I want to graph sine or cosine, there are 5 key points on each wave. One of the points is the maximum, one of the points is the minimum, and there's 3 intercepts. So again, there's the sine wave. Starts at 0, 0, reaches a maximum of 1 at pi over 2, returns to 0 at pi, hits a minimum value of negative 1 at 3 pi over 2, and then returns to 0 at 2 pi. Again, cosine, 5 key points to keep track of: the minimum, the maximum, and the intercepts. Cosine starts at its maximum at 0, 1, slowly goes down to 0 at pi over 2, hits the minimum value of negative 1 at pi, slowly returns back to the value of 0 at 3 pi over 2, returns to its maximum value of 1 at 2 pi. Again, the period is 2 pi, whether we're talking about the sine function or the cosine function, as long as we've not manipulated the functions at all. Now, if you remember when we worked with the parabola, it was real easy to figure out how we were transforming it. So let's quickly remember what our vertical and horizontal translations did. Our basic parabola was y equals x squared. It would make a U shape, a parabola shape. So if I've got, say y equals x squared plus 3, it shifts it up 3 units. If I have x squared minus 4, it would shift the parabola down 4 units. If it's inside the parentheses, I've got to think opposite. So if I see x plus 7, it's actually going to slide to -7, which means it's going to the left. If I see something like x minus 2 inside the parentheses, I've got to think opposite. It'll actually slide to +2, which means it's moving right 2 units. The sine and cosine function will work very similarly. If we just add a number in back, it'll lift the function up. Subtract a number in back, it'll drop the function down. But if the addition or subtraction occurs inside parentheses with the variable, then we're shifting left and right. We're going horizontally instead. Again, our basic sine wave. So if I put a +3 in back, it'll lift the whole curve up 3 units. If I put a -4 in back, it drops the whole curve down 4 units. Now, what if I want to do the addition of 7 first before I apply it to the sine function? Well, we're shifting left 7 units. Again, because of the parentheses, we're shifting right 2 units. Right? The difference is whether or not we want to do the addition or subtraction first, or whether we want to use the sine function first. Now, the big difference, though, is that there's 2 different ways a coefficient can affect the graph. Because the coefficient can either be just on the variable, or the coefficient could be on the function. So if I don't see a coefficient on the function, I know it's 1, right? That's just 1 times the sine of x. So I know the maximum value is 1. I know the minimum value is -1. I say the amplitude is 1. But what if I put a 5 in front? What if I did y equals 5 times the sine of x? Now the sine function has a maximum value of 5 and a minimum value of -5. So now we'd say the amplitude is 5. What if I put a -7 as a coefficient on the function? Y equals -7 times the sine of x. Now the maximum value is 7. The minimum value is -7. I'd say the amplitude is 7. Notice that even though that's a -7 on sine of x, I still say that the amplitude is 7. The amplitude is always positive. If this doesn't make sense to you, say, hey, how can the amplitude be 1 if it's going up to +1 and down to -1? Think about being in a boat out in the water, and they start talking about, the water might have a 1-foot swell or a 3-foot swell. That means the crest of the wave is 3 feet above where the normal surface of the water would be, and then the trough of the wave would be 3 feet below where the surface of the water would normally be. So when we're going between +1, -1, +1, -1, yeah, the total up and down distance may seem like it's 2, but we're just going like 1 unit above where we should be, and then 1 unit below where we should be, and so that's why you say the amplitude's 1. Same thing, if it's going between +5 and -5, yeah, I understand that the total distance from the maximum to the minimum might appear to be 10, and it is 10, but we'd say the amplitude's 5, because we're going 5 above the average value to the maximum. We go 5 below the average value to hit the minimum. Now, if I don't see a coefficient on the variable, I know it's 1. And the period, therefore, is going to be 2 pi. Now, if I place a coefficient on the variable, it affects the period. We take the period of 2 pi and we divide it by the coefficient of the variable. So if I've got y equals sine of 4x, the period becomes 2 pi divided by 4, which reduces the pi over 2. So instead of taking 2 pi units for one complete period, it only takes pi over 2 units. Think about hitting the gas pedal. When I put the 4 on the X, I'm saying, hey, I'm going to drive 4 times as fast. I'm hitting the gas pedal and I'm increasing my speed. Well, if I increase my speed, it takes less time to get there. If I can drive my car 4 times as fast, it only takes me 1/4 the time to arrive at my destination. So if I'm going to go through that variable 4 times as quickly as usual, the period only needs to be 1/4 the length. What if I've got y equals sine of pi over 3x? Again, the coefficient is on the variable x, not on the sine function. So the period, well, it's always 2 pi divided by the coefficient on the x. So 2 pi divided by pi over 3, that of course is going to become 6. Right? Pi over 3 is just a little bit more than 1. 6 is just a little bit less than 2 pi. Okay, so let's see. Can we actually graph these by hand without using technology? I don't want to use a graphing calculator. I don't want to go to Desmos. I want to make sure I can understand what's happening. Well, I know the sine function would normally start at 0, 0. And it would go up to 1, return to 0, go down to -1, return to 0. And it would do that in a period of 2 pi. That's what the that's what the sine function should look like. Well, what is the 2 on the sine of x doing? It makes the amplitude 2. So instead of just going up to 1, I should go up to 2. Instead of going down to -1, I should go down to -2. And so the sine wave should look like that. Starts at 0, goes all the way up to 2, returns to 0, goes all the way down to -2, returns to 0, does that in a span of 2 pi radians. Oh, hey, there's a +1 in back. It's going to lift that entire curve up 1 unit. Lift that point up 1 unit, 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 and there it is. The amplitude is 2 because there's a 2 multiplying the sine of x, and then the +1 in back lifts the whole function up 1 unit. But of course, it's going to want to go on forever in both directions. And so there in yellow is the graph of y equals 2 sine of x plus 1. Now on any assignment, if you get super duper stuck, yeah, you can always try to do it and then check using technology. Or if you're really stuck, use the technology to see what the answer should look like, and then reverse engineer and say, okay, now that I know what the answer should look like, how could I do that by hand? Okay, another example. Y equals 3 times the sine of 2x. Now, the period is normally 2 pi, but there is a 2 as a coefficient on that x. So the period is going to be 2 pi divided by 2, which is just pi. So one complete cycle has to happen between 0 and pi. And of course, that 3 as the coefficient on the sine function tells me the amplitude is 3. So I need to start at 0. I need to go all the way up to 3, return to 0, go all the way down to -3, and return to 0. And I need to do that complete cycle in just pi units. So pi over 2 is where I return to 0. Pi over 4 is my maximum. 3 pi over 4 is my minimum. There is one complete cycle with a period of pi, amplitude of 3. And of course, it keeps going forever in both directions. Here is the generic equation. Y equals A times the sine of the quantity bx plus c plus d. Of course, A is my amplitude, and of course I also have to take positive, so I put an absolute value symbol. Right? If there's a 3 out in front, the amplitude is 3. If there's a negative 8 out in front, the amplitude is 8. The B affects the period. The period would normally be 2 pi. However, if I see a number on x, the period becomes 2 pi divided by that number. Vertical shift is d. If d is a positive number, it'll go up. If d is a negative number, it'll go down. What you see is what you get on vertical shifts. That's nice. Now, the horizontal shift is not just c units. It would be just c units if that was a plain old x in there, but sometimes that x has a coefficient. And so the horizontal shift, instead of just being c, is actually going to be c divided by b. Now, if there's no coefficient on x, c divided by 1 still comes out as c. But then the other little thing you got to remember, when it's inside the parentheses, you got to think oppositville. So even though the left or right movement would be c units, we have to do the opposite. So if c is positive, we're actually going to go negative. If c is negative, we'll actually go positive. Homework, IXL and 4, graph the sine functions.